Good evening, everyone, and welcome to the latest in the Royal Nautical Society Boscombe Down Branch lecture series. And I'm delighted to welcome Jamie Sayer as our guest speaker for this evening. And he'll be talking about quite a challenging topic, actually. It's all about uncrewed air systems and how they're regulated, and I think that'll be a really interesting and I'm sure technically challenging lecture for this evening. So a quick introduction to Jamie, who has recently joined us at Kinetic with a long and an impressive career, both with the Royal Navy and subsequently. He is an air engineering officer by trade. He's worked with Sea Harriers, he's worked with 845, which will be Sea King. He's done a number of tours with the MOD at Abbey Wood in procurement, including working on the F-35 Lightning II, and then ended up as his last role in the Royal Navy as Type Airworthiness Authority for unmanned or uncrewed air systems. And since he left the Royal Navy, Jamie has been working in a number of organisations, most recently Kinetic, on system safety and autonomous systems in particular, and has a wealth of experience in risk and safety management. And so a warm welcome this evening, Jamie, and I really look forward to hearing your presentation and getting the chance to ask you a few questions afterwards.
Thanks very much, Nick. Delighted to be able to present to you tonight on what could be quite a dry subject. I'll try and keep it interesting, but I think if we invite questions as we go along, that might break from my monotonous tones. So back in 2019, before I left the Navy, actually between 2017 and 2019, I was Type Airworthiness Authority for some tactical UAS, delivering safe and reliable systems to the MOD. And during that period, three things happened and converged. One was that I was delivering those tactical systems to the MOD. The other thing was that I got invited to become co-chair of a NATO technical panel, which was looking at how to harmonise regulations across NATO for approval of UAS operations. And thirdly, I got invited to have a chat with the military regulator, the MAA, who were fed up with every UK military unit with a corporate credit card going out and buying a drone for use on their military unit, some of which were less reliable than others. And the MAA wanted to remind units that they had to seek approval for the use of drones, and they had to seek approval from a UK Type Airworthiness Authority. So they asked me and my team to set up a process whereby we challenged and assessed drone operators around the world in order to provide reliable and safe airworthy drones for the UK. And that was a project called Airborne Pilgrim, which is still running today. All right, moving on. NATO Applied Vehicle Technology Panel 278 was a 3-year program looking at risk-based safety assessment of operational airworthiness and certification requirements for essentially drones. And our challenge was to find a recommendation for a clear and baseline equivalent level of safety to assist in obtaining operational approvals for RPAS operations utilised by NATO. And it was recommended that it would also require civil acceptance because NATO operations aren't clearly restricted to military areas. So often they fly in civil aerospace and over populated areas. At the time, and it's still the case today, there are obviously operational approved RPAS drones with varying degrees of airworthiness that lack standard formal approval processes. Many members of NATO have non-standard organisational processes, and there's many different services and manufacturers, and many of these processes are still evolving. And clearly at the time we were looking at civilian regulations and military regulations, and we were looking closely at what JARAS were doing with their specific operational risk assurance, which is now published. The desired end state was a recommendation for a clear and formal process for the approval of RPAS operations utilised by NATO, and it should serve as a basis for harmonisation between NATO member countries. Effectively, there's a bit more detail about what topics were covered. We looked at various risk-based safety assessment methodology. For example, we looked at procedures for mitigating operational risk, and we looked at technologies, and we looked at lessons learned from analysis of national and international RPAS programs. We'll come on to what we call the 9 considerations later, but we did derive a target level of safety for airworthiness assessment, and that was based upon something that was called the commander range safety equation, which we may come on to later. Team leaders were Jörg Dietrich from Germany and me, and there were a number of nationalities from NATO involved: USA, Germany, Italy, Britain, Poland, Portugal and Turkey. And it's suffice to say that trying to corral NATO into common thinking is difficult at the best of times, although seems to have been resolved by Putin more recently. But it was like the 2-year program, 2 or 3 year program was a bit like herding cats at times. So it was a 3-year technological activity to analyse the impact of risk-based approach on RPAS operations in the military and civilian world, analyse countries' individual approaches to military RPAS approvals, and they did vary significantly. Some had very efficient processes, some had long-winded approaches, some had one single place of accountability, and others had many. And that was our ultimate aim, was to make the recommendations for harmonisation and approval of RPAS operations. At the time, as I said, the civilian world was making a paradigm shift to risk-based methods, with the specific RPAS category and the JARIS working group at the time. A similar process were being applied in the military sphere, and we often talk now about risk-based certification and risk-based operations. So we gathered a whole list of which specific operational risk assessments exist, what had already been applied to the aerospace domain, and we assessed their pros and cons with input from experienced SMEs. The ultimate consideration, and this remains very true in circumstances today that are obvious, is that the regulation consideration must be sufficient to support authorities in balancing operational objectives with safety and risk management accountabilities necessary for authorising UAS operations. Essentially, the benefit must outweigh the risks. And ultimately, in a NATO operation, the risk will lie with the commander in theatre. So following normal NATO principles of escalating the risks to the commander or duty holder in theatre, the benefits of operating UAS must outweigh the risks. And obviously you'll see that today in a war situation in Ukraine, where there's probably very great benefits to be had in flying drones over that theatre and very little risk. However, I would say that what I'm about to tell you in the 9 considerations are also essential for producing UAS and drones that are reliable. It's no use having a drone that can be very effective in a situation if it's going to just fall out of the sky. The founding principles of our approach to harmonisation of the regulations were based upon good ICAO and EASA policies on manned aviation regulations and operations policies. And those are appropriate and proportionate certification evidence, which is risk-based, the use of competent design organisations and methods of assurance, and operations legislation, rules and authorised, qualified and competent operators. And those are fundamental principles of manned aviation. So the 9 considerations are these, and it's, you know, this isn't rocket science, it's common sense, but that's easy to say when you've been in aviation for 25 to 30 years. Some of the tech startups that I have seen and assessed belong in the domain of individuals who have been very successful with sort of software engineers. A lot of them came from the telephone industry, and many of them aren't aviation experienced. So actually, whilst it's easy for some of us aviation engineers to talk about competence, integration, conformity with standards, scrutiny processes, build quality, safety management systems, having proper flight envelopes and limits, and having appropriate manuals, many of these topics are very new to CEOs of tech startups in the drone industry. And whilst me and my team very much provided safe and airworthy products to the MOD, I can tell you we also bore witness to some disasters that didn't end up in service. At the time, EASA were trying to decide what to do about introducing a regulatory framework for the operation of drones. And EASA eventually produced 2019-945, which is the regulation that introduces European certification of conformity, CE marking. And the EASA policy options at the time were do nothing. We're going to ask, scenario one was we will insist on authorising all UAS operations. Scenario two was we will authorise some situations and we will have standard scenarios. And scenario three was that we will authorise drone operations, have standard scenarios, but also issue a light UAS operator certificate, which meant that if you'd been approved by EASA, you could authorise your own operations. We considered the worst case scenario, which is that you would have to go case by case to EASA or a national authority to authorise all operations. And we looked at the production of the risk assessment, which had to include all those bullets there. And we looked at the 9 considerations that I'm going to tell you about in a second, and considered whether we had covered all of the EASA worst case scenario. And indeed, we found that we did. So when looking at the operational area of the UAS and related conditions, that was covered by item 5. The category of airspace and effects on other traffic, that was covered by item 7. Design features and performance of the UAS was items 1 and 5. The types of UAS operation, item 5. Competence of remote pilots, item 2. Organisational factors, effects of the UAS operation on the environment, and targets level of safety. So we had covered the worst case scenario for the EASA proposed policy, which is now 2019-945. So without further ado, getting into the 9 considerations then. The 9 considerations effectively asked NATO operators to provide solutions. By providing solutions, the organisation will ensure an adequate level of safety, facilitating inclusion into cross-border UAS operations. There was pushback from some nations, and we reached an agreement that any gaps against the 9 considerations would require remedial risk to be presented and argued to the relevant notified bodies or to the commander in theatre. So on to the first one. The first consideration was that the entity operates with an airworthiness framework that ensures they contract UAS capability with competent design organisations. And the JARAS specific operational risk assurance methodology refers to the requirement for UAS to be manufactured by competent proven entities. And the level of rigour of assurance is dependent upon the risk class of the operation. And things that should be considered, and this is covered in those operational specific principles in the JARAS SORA, is things like configuration, build quality, employment of competent persons, safety management culture, and provision of accurate instructions. This is covered in EASA 945 conformity assessment. You were needed to provide evidence for If it's a lightweight class 0 drone, i.e. below 250 kilograms, you can provide the evidence yourself. But if you're in the class 1, 2 or 3 situation, then a notified body will assess your framework, your airworthiness competencies. Second consideration is that the entity employs competent personnel in the approval and operation of UAS. Expected levels of training for certain individuals with important roles. In the MOD and in some other nations in NATO, we talk about type airworthiness authorities or chief engineers, an individual accountable for managing the safety of type, and we talk about duty holders or operators being accountable for managing operations. And in civilian space, we often talk about Form 4s or having operator's license. For smaller systems, we recognise that an accountable individual must be identified, and EASA 947 covers the exams for those types of individuals. And there are elements in the JARASORA that covers operational safety objectives for this type. Again, EASA talks about forward operations and continual airworthiness aspects in Articles 7, 8 and 9 for competency, and in the the specific class in the light unmanned operator certificate for specific operation. Item 3, the entity operates with an airworthiness framework that considers the need for certification or compliance with appropriate standards and gathers the evidence for or against this need. And the NATO framework steers towards appropriate determinations of the use of standards, and this includes an assessment of class categories against a specific set of characteristics and operational circumstances. More of that in a second. And this is covered in EASA 945. Part 10.4 requires descriptions of solutions to meet essential requirements and a list of relevant technical specifications. Part 10.10 in EASA 945 requires evidence supporting the adequacy of technical design. And this is also covered in the specific category and requirements for providing a light unmanned air system certificate. And some of you might be familiar with this. In the UK MOD, we had Regulation 1600 that effectively said if you were a very heavy, very fast drone carrying weapons, then you needed full regulatory assurance certification, i.e. you in the tight top right-hand corner. You were applying manned principles and manned certification. In the middle here, there was a dodgy ground where you had tailored certification with appropriate design airworthiness and continuing airworthiness. And this Class 1C and Class 1D area was very difficult because you had to argue why you weren't compliant with certification standards, take a risk-based approach, and then argue why it was safe to do so. And then, of course, you're down here in the bottom left-hand corner with the nano drones. You're operating with due regard, and some of you might be familiar with the UK operation of Black Hornet, which was a very lightweight drone, which a military operator once told me that the only way a Black Hornet was going to harm you is if I taped it to my fist and repeatedly punched you in the face with it. Moving on to EASA class categories then. 945 covers those open classes, which are mainly based on weight, but they have some particular technical features. Class 4 is for the remote aircraft hobbyists. And there was some specific was when you're typically flying beyond visual line of sight, but in theory you could be flying a heavy drone. And then there was this kind of myth where 150 kilograms was the limit where you could get away without being certified, and many startups went out and provided high altitude pseudo satellite systems that were just below 150 kilograms. But then EASA came out with a rule that said we will look to certify systems that are 150 kilograms and below. So essentially, with the light unmanned air system certificate, you could be operating anywhere here. So you could be operating certified or specific or open drones, provided you had approval from national authorities. Up here, manned aviation regulations could apply, but you had these questionable areas where you could be quite heavy, but in a low risk line of sight environment or operating somewhere over the sea, or you could be, as I said, very lightweight, using Black Hornet, for example, but operating in a highly risky environment. So that was referring back to item 3, that you had to consider your operations and other factors that that would lead you to decide whether you needed to certify a system. And very much the Jarasora methodology talks about this in detail. More about Jarasora later on. So consideration 4 was that the entity had a method of ensuring build quality and maintaining that build quality. We reached a conclusion that we should insist on known QMS standards or equivalents, and there we were talking about ISO 9001 or AS 9100. So those typically recognized standards in manned aviation. There are many standards out there now for drone design and operations, and ASTM is a particularly good one. There are EASA standards, and there are ISO and BSI standards being published right now. Jarasora refers to a need to produce a list of adequate industry standards to be identified by EuroK Working Group 105 by September 2019, and some of that work has been completed. Going back to the EASA 945, Article 6 and 10, these are obligations of manufacturers, importers and distributors that have certain requirements to rely on certain standards. And 947 Article 11, if you're talking about the specific risk assessment, specific operations, you have a requirement to rely on known standards, and you have to provide a conformity assessment for classes 1 to 3. So why does that matter? So here's a section of the Air Accident Investigation Board report on the Air Lauda Airspeeder loss of control, which for some of you who aren't familiar, this was a prototype that was given approval by the CAA. So apologies for any CAA members who have joined tonight. You're going to come in for a little bit of criticism. The Air Lauda Airspeeder was lost, resulting in a flyaway and eventual crash at Goodwood Aerodrome, West Sussex. I believe the crash might have happened near Gatwick Airport, actually. It had a ground-based kill switch. Unfortunately, there's a picture of the ground-based kill switch on the left there, and it shows a Chinese knockoff of a popular hobby programmable microcontroller. It's a £1.30 Chinese microcontroller with known poor reliability. The power regulators on them randomly die for no reason at all. It sits on a standard breadboard header pins connected to development board attached to a hobby telemetry module. Now, assessment of drones clearly cannot be carried out by just anybody. You have to have a little bit of aviation technical knowledge and savvy to be able to assess and provide adequate assurance of drone operations. And one might say at the time that the Airspeeder was granted an operational approval, perhaps the CAA weren't in the best place to make that assessment and probably didn't have a framework to rely on to make that assessment. And I believe the CAA are now working on something called the Flight Assessment Entity, which they will be used for making UAS assessments. Bottom line is the ground-based kill switch did not work when the Airspeeder went lost link and went out of control. So item 5, The entity has gathered evidence to support the operating envelope of the EAS and has applied constraints, limitations where necessary, appropriate to the operation. I think that's pretty obvious to most of us operating in manned aviation for years. The framework stipulates the requirement to support operational use with appropriate test evidence against the flight envelope. And Jarasora talks about best practice. Yes, industry data and those nice glossy specification sheets do not often stand up to scrutiny, and particular claims of endurance drastically reduce when operating in high tempo environments, changing altitudes, high temperatures and even low temperatures, and sophisticated or not even sophisticated use of payloads and repeated use of payloads. And I can tell you of one incident where we were using a drone in the MOD that was very good at taking high definition images, but we subsequently found out the processing of those high definite images was being routed to the same processor that was trying to do the C2 telemetry. And the resulting buffering had implications for trying to operate that drone. 945 Part 10 talks about elements for evidence supporting the UAS design and operations. And another good example is poor old Watchkeeper, which was originally bought with the intention to operate in rain and icing conditions, suffered a couple of accidents, one over West Wales, where the humidity sensors that were employed in the Watchkeeper to detect icing didn't have the range whereby icing would be detected by that humidity sensor. So clearly not having the range to detect icing, Watchkeeper then subsequently got into icing and became a submarine very quickly after that. So another example, again about the air loud, sorry, go back previous. About the ground-based kill switch again, previous flights in Australia have been performed using a frequency of that 950 megahertz and transmitter power of 1 watt. The operator indicated in the operational safety case that was provided to the CAA that due to UK regulations for this frequency, the transmitter power had to be limited to 25 milliwatts. When the transmitter was examined post-accident, it had been set to a non-EU mode with a power of 10 milliwatts. 10 milliwatts of transmitted power is only sufficient for indoor flying and will not provide any meaningful ranges in outdoor environment, especially given the receiving antenna is buried inside the aircraft fiberglass shell. So perhaps another reason why assessments have to be appropriate. And I've got no idea why they've shown a picture of someone sitting inside the Airspeeder. Clearly on that day it would not have been great to have somebody sitting inside it. I'll try and race along now. Consideration 6, the entity has employed methods of independent scrutiny to assure the safety assessment of their UAS. The NATO framework insists on the US organisation having subjected safety cases to independent scrutiny, depending on the type weight of the UAS, which could be the notified body if you're using EASA 945 regulations. Independent valuation should be proportionate to the level of risk, which we talked about already. And yes, all part of Part 8 and 9 conformity assessment in 945. Pretty straightforward one. 7, having a safety management system that includes the usual things and the ability to manage failure reportive and corrective action systems. I mentioned this earlier. For the NATO framework, we recommended a set of safety equations to record the risk to life, and this was based upon the range safety equation, which is that the casualty exposure factor, the probability of equipment failure, population density, the lethal area in the event of flight into terrain, probability of fatality, and a shelter factor. If you want more detail on that, please reach out to me. I won't go into the detail here. And we wanted a similar methodology for calculating air encounter risk. So those who know the Jarasora will appreciate that Jarasora has methods for both calculating ground risk and air risk. But actually in the NATO framework, we came up with ideas of how you could calculate improved air encounter risk, which would be based upon airspace density. But it's granted that calculating the probability of mid-air collision on operations can be challenging and should be supported by intelligence to minimise the likelihood further. And as I said, airspaces could be calculated similar ways to population density, and you'll be appreciating that in some areas it is certainly necessary to fly in contested airspace on certain occasions. Again, EASA 945 has a requirement for risk assessments to be provided by the operator in order to obtain operational authorizations. And 947 mentions this in the specific category and in Article 11. 8, the entity provides professional UAS documentation, including the operator's manual and maintenance manual and records. Pretty straightforward. And flying orders should be provided that include these things. And this is very familiar ground for those of you who understand the EASA 945 and 947. Responsibilities of the operator to provide operational procedures. Finally, item 9, the UAS is technology integrated in the system that facilitates safe navigation and separation when operating over densely populated areas and in competing airspace, or can argue sufficient mitigations. And there's a lot in the final paper that was delivered in December 2019 on this about how you deliver air traffic control live picture to the operator and vice versa. JARA-SORA methodology offers practice here for calculating the risk and assurance levels required, but we questioned whether there was a better methodology and questioned how does residual risk get communicated to the appropriate authorities. And you'll appreciate that there are now coming online many technologies to assist in that air traffic live picture, such as using detect and avoid systems, ADS-B, FLARM, etc. UTM is out there and is being covered by lots of national authorities and EASA, etc. And it's covered in 947. Specific parts of that 040 includes coordination, requirements to coordinate airspace. For those of you that aren't familiar with the joint authorities for rulemaking of unmanned air systems, the purpose of the SORA was to propose a methodology for risk assessment required to support the application to operate unmanned air systems within the specific category mainly, and it was based upon likelihood of fatal injuries to third parties on the ground, equal likelihood of having your UAS operation out of control, and then the likelihood of a person being struck by the UAS if the operation is out of control, and the likelihood that the person is struck is killed. And that still remains the case in JARA-SORA today.
Thank you very much, Jamie. And that was really interesting from somebody who has got a professional interest in this as accountable manager for uncrewed air systems at Kinetic. I found that really quite an interesting exposition, and you've gone through that really thoroughly. And it kind of reminds me of where we are in drones as a whole, in that we're sort of moving from the Wild West, if you like, of the early days of uncrewed air systems and drones into the much more familiar regulated environment that we see with manned aircraft, with crewed aircraft. Thank you very much for that. I think that's given us a really great insight into this developing area, and so I'd just like to really close by thanking you, Jamie, for giving up your time tonight and taking us through the world of airworthiness and certification for uncrewed air systems and drones, and just giving us an insight into how this is developing and the challenges that are being faced and the ways that that regulators are looking at resolving those issues that come out of this really exciting sphere of aerospace development. So that concludes our lecture this evening. Again, many thanks, Jamie. So just for me to say finally that our next lecture will be on the 5th of April. And as I said before, it's about the aircraft accident case study of the loss of Lion Air flight JT610. And very much look forward to seeing and hearing from as many as you are able to attend then. So thank you very much and good night.
Cheers all. Thanks.